Hey everyone, welcome back from spring break. Today we're going to be doing the second part of section 8.4. And I know it's been a while since we talked about section 8.4, so I just wanted to review a couple of things from page 83 just to help you remember some stuff, and then we'll move on to page 84 in a second. So we talked about particles in solution on page 83, and we talked about how ionic compounds break into smaller particles when they dissolve, but covalent compounds do not break into smaller particles. And you need to remember for this section that ionic compounds are made of a metal and a nonmetal. So remember, the metals are on the left of this red line except for H, and the nonmetals are on the right of this red line, and then hydrogen is a nonmetal also. So we looked at a couple of examples and we figured out how many particles they would form when they're dissolved. So for example, NH3 is all nonmetals, so it's covalent, so it's not going to split into particles, so it stays as one particle. Then we had some ionic compounds, and for example, KF is made of 2 ions, so it splits into 2 particles. MgCl2 is made of 3, so it splits into 3 particles. FeCl3 is made of 4, so it splits into 4 particles, and CH3OH is covalent, so it doesn't split into particles, it just stays as 1 particle. And then this one was a little bit weird, it was CaCO3, and CO3 was a polyatomic ion, so it's still ionic, but it just splits into 2 particles, because the polyatomic ion counts as 1 particle. Okay, so that's important to remember for this next section. So now, we're going to move over to page 84, and we're going to just take a couple of notes and do a couple of examples, and then you should be able to answer the questions for the assignment. So, we need to write down the definition of something called colligative properties. So, colligative properties are properties, obviously, that depend on the concentration of particles in a solution, but not the type. Okay, so that probably seems a little bit vague and confusing, but it'll make more sense in a second. You need to remember, though, that it depends on the concentration of particles. That's the definition of colligative properties. So there are 2 specific colligative properties that you need to know about, and one of them is called boiling point elevation. And this colligative property tells us that if you add a solute, so if you dissolve anything in water, that is going to raise the boiling point. Okay, and that's why it's called boiling point elevation, because elevate means to raise. And so adding something, dissolving it in water, will raise the boiling point. It's a colligative property because it doesn't matter what you dissolve, it just matters how many particles it splits into. So the more particles you have, the more the boiling point will go up. And we'll talk a little bit more about that in a second. The other colligative property you need to know is called freezing point depression. And this is the opposite of boiling point elevation. So adding a solute to water will decrease or lower the freezing point. Okay, and this has a lot of really important applications. This is why we put salt on the roads, because it will help water to not freeze on the roads because it will lower the freezing point. So with all of these colligative properties, if you have a greater concentration of particles, that means you're going to have a greater change in boiling or freezing point. Okay, so a couple of examples and then we will be done. All right, example 1. So you're going to get lots of questions that say which of the following would have the highest boiling point. All right, and then I'm going to give you a list of different solutions with their concentrations. So 0.2 lowercase m KCl. Now this lowercase m, you might remember, stands for molality. It's a unit of concentration, and remember it's the one that's moles over kilograms. So it doesn't change when temperature changes, and that's why we use it for colligative properties, because colligative properties have to do with change in temperature. Now you don't have to worry about that this is moles per kilogram. That's not going to make a difference in these questions, but just so you know what that lowercase m is. So 0.2 molality KCl, 0.2 molality NaCl, and 0.2 molality CaCl2. So we know that if we have a bigger concentration of particles, we're going to have a bigger change in the boiling or freezing point. Now these all seem to have the same concentration, but they all break into particles too. And we know they all break into particles because they're ionic. Let me just show you really quick that they are ionic. So KCl is a metal, and Cl is right here. It's a nonmetal. So we know that one's ionic. Na is also a metal. We already saw Cl is a nonmetal, and calcium is also a metal. So those are all ionic. Now, since these all have the same concentration, whichever one breaks into the most particles will have the greatest overall concentration. So you're looking for the one with the most particles. So this one is going to split into 2 particles. This one is going to split into 2 particles, but this one is going to split into 3. Okay, and if you wanted to, you could actually calculate the concentration of particles by multiplying this number by this number. So this would have 0.4 molality of particles, 0.4 molality of particles, and 0.6 molality of particles. You don't have to do that calculation, but if that helps it make sense, you can. But basically, you're just looking for the one with the most particles. So calcium chloride, CaCl2, this one would have the highest boiling point because you have a greater concentration of particles. Okay, I'm just going to show you one more example. And then we will be done. All right, so example 2. Which of the following would have the lowest freezing point? Okay, so if we're looking for the lowest freezing point, we're still looking for the greatest concentration, because the higher the concentration, the lower the freezing point. Okay, so we got 4 solutions this time. We need to figure out whether they are ionic or covalent and how many particles they split into. So this one is ionic, we saw last time. This one is ionic. Aluminum is a metal and chlorine is a nonmetal, so that's ionic. This one has CH and O. Those are all nonmetals. So C is a nonmetal, O is a nonmetal, and so is H. So this one's going to be covalent. So this one will split into 2 particles, NaCl will split into 2. This one is covalent, CH3OH. It will stay as 1 particle. This one, AlCl3, will split into 4 particles. And CaCl2 will split into 3 particles. So the lowest freezing point is going to be the highest concentration. So it'll be this guy, the aluminum chloride. All right, so this would be a good thing to put on the roads as long as it wasn't too expensive and didn't damage the roads. And since we don't put it on the roads, it's probably one of those 2 things. It's either damaging or expensive. We actually usually put CaCl2 on the roads to keep water from freezing. So those are the types of questions you're going to have. It really is just looking for which one splits up into the most particles. It's not too bad. So good luck, and I hope you have a good week.